2 is on more practice with volume, so I meant to do this before we did the cross sections, but I didn't, so it's kind of good that we're doing this after spring break. All right, so the first one says find the volume of the solid generated by revolving the region bounded by the graphs around the indicated lines. Okay, so we have y equals 1/2 x cubed. We have y equals 4. And we have x equals 0. So what happens is we have this little shaded region right here that's going to be revolved. And we're revolving it around the line y equals 4. Okay, so if you guys remember, when we do these solids of revolution, we only have this like disc and washer method. There is another method called the shell method that they learned in DC, but we're only doing disc and washer and AB. And so what we say is, do we have a horizontal axis like the x-axis, or do we have a vertical like the y? And we have a horizontal axis. Do you guys see that? So if we have a horizontal axis, then we want to integrate with respect to x. So in our equation, we're going to have like a dx at the end. Okay? Everything in that equation is going to have x values. So I'm going to go from an x value to an x value, and all of this stuff here is going to be in terms of x. Okay? So we want to know what x value we're going from. Okay, so I want to know from 0 to whatever this intersection point is. Okay, so I need to find that intersection point. So something I was telling first period today is, you know, as an AP teacher, I just sometimes just found that intersection point like on the calculator, right? And I never wrote an equation down. And apparently, years later, I found out that my students are missing points for that. Whoops. So we have to write some kind of equation that shows that we're finding that intersection point. So we could write like 1/2 x cubed is equal to 4, right? Because that's what we're finding. We're finding when our cubic function intersects the y equals 4 line. And so we would get x cubed equals 8, so we could have x is equal to 2. So that point right there is 2 comma something. It's actually 2 comma 4 because it was a y value of 4, right? And this other point was 0, 0, obviously. So our x values are going from 0 to 2. So as we're revolving this, we get circular cross sections. This is when I talked about like the pottery wheel, right? As you're spinning things around, you have these like circular cross sections. So as we spin this, we get this like bowl shape on its side, right? Is there an inner part that's like scooped out? Imagine I'm taking clay and I'm scooping something out. No, it's just all solid, right? So in that case, there's going to be what we call an outer radius, but not an inner radius, okay? So that outer radius is always from the axis of rotation to the outside of the shaded region. Every single person that continues to ask me questions about these sections is not drawing a shaded region. Lydia, Lydia. So you need to draw the shaded region. Otherwise, you're not going to know what you're doing because you need to find the outer radius and inner radius, okay? So draw the shaded region. So our outer radius then is going to go from this axis of rotation all the way to the outside of that shape. So this is where I had been talking about if I'm at a height of 15 and I go to a height of -1, that distance is 15 minus a -1, right? It's going to be a total of 16. We see that. We do the top line minus the bottom line. So in this case, what is our top line and what's our bottom line? The top line is 4 and the bottom line is exactly. So we have 4 minus 1/2 x cubed. That's our outer radius. Do we see that? And so that's what we put into this equation. So the easiest way to write it is to just do pi r squared dx. And as long as you've written what capital R is, you're fine. The only time that I would be concerned about that is if sometimes the AP test will say region R is defined by blah, blah, blah. If they're already calling it region R, don't use R, right? Use something else for your outer radius. Sometimes I'll do like r sub 1, right? But as long as you're writing it that way, you have your full points for setup. So we do pi from 0 to 2, 4 minus 1/2 x cubed squared. So the reason I recommend to write it with the capital R squared is everybody always forgets the squared here. I don't know why. It's just you write all that stuff down for your outer radius and you're like, okay, I'm good. And you forget your squared. Can you guys continue from there? Do you all remember Math 9? All right, I won't make you find it. We can just do the setup, that's fine. All right, so this next one, we have 6 minus 2x minus x squared, and we have y equals x plus 6. Although I think you could graph this by hand, we're actually going to do this one on the calculator because then we're going to practice using our calculator. So I want you to put that parabola, which is a downwards parabola, right, in for y1. So we're going to do 6 minus 2x minus x squared. and we're going to put x plus 6. Now the reason I'm doing this on the calculator is because it's a downwards parabola, but I can't really tell where the x-intercepts are. They're not nice x-intercepts. It's kind of hard to graph if you were trying to do the x-intercepts, but you could do a t-table and you could get a pretty rough sketch. Or negative b over 2a, remember that one? Let's find the maximum. So we're putting those two equations in, and then we hit graph. So we have our downwards parabola, and it's intersecting our line. Can you see it? Okay. So we want these two intersection points. Okay, so we can find them. So we do second, trace, intersect. And the first one looks like it's on the x-axis. If I wasn't sure, could I easily plug that into my head? Like if I plug in 0, what do you get? 6. If I plug in 0, do I get 6? Yeah, it's actually 0, 6, but if you do first curve, second curve guess, it does give you 0, 6. Yep, when I did this earlier, I got -7 point something times 10 to the negative 14th. Yeah, look at the, do you see the times 10 to the negative 15 or whatever? Yeah, that's basically 0. It's just a rounding error. All right, so then second trace, intersect, and we find this other one. First curve, second curve. So I get -3, 3. So we have this downwards parabola. It's intersecting. Whoops, I did not intersect that in the right spot. Because it's down here, right? No, it's -3, 3. It was above the axis. I can't draw. So it's something like that. There's my shaded region. Very important to draw, right? Super important. All right, and now we're going around the x-axis. So again, if it's a horizontal axis, like the x-axis, we integrate with respect to x. So I'm going to do v, and I'm going to have my pi, and I'm going to have a dx on the end. And so sometimes I write that so I remember, okay, everything's in terms of x. All right, so I'm going to have an outer radius going all the way to the outside of the shaded region. That's what an outer radius means. And I have an inner radius going from the axis of rotation to the inside of the shaded region. So I have a big R and I have a little r. So my big R goes from the top of the curve to the axis of rotation, this distance here. What am I going to use? Yep, 6 minus 2x minus x squared. You can put -0 if you want. But since it's the x-axis as well, it's just -0. All right, and then the other distance, this distance. Yep, x plus 6, you got it. And the x values go from, we need to find, that was the intersection point -3, 3, and that was the intersection point 0, 6. So what x values do I go from? 0. -3 to 0. So as long as I have this written somewhere on my paper, I'm good. That's my setup. If you wanted to put in your x's, you can. I would just do that on the second part. So you're still getting your setup for that first thing you wrote. So it looks like that. And then you could math 9 that and give your answer. I wouldn't recommend doing it by hand. It looks kind of annoying to do by hand. Yay, math 9. All right, so around the line y equals 3. So if we're going around the line y equals 3, our whole graph is going around this line right here. So we had our little curve. Oops, I missed it. Big point, right? And it's going around that line right there. Do you do that too? Just make it a big point when you miss it. All right, so this has an outer radius and an inner radius. These are basically the same outer radius and inner radius that we had before, except now we're like losing 3 units. Right? Do you guys understand that? So we're going to write it like big R is equal to our top curve, which was 6 minus 2x minus x squared minus 3, because that's the bottom curve, right? Top was the parabola minus the 3 line. So it ends up being 3 minus 2x minus x squared. And then our inner radius is going to be the x plus 6 minus the 3, right? So it ends up being x plus 3. Same setup. So -3 to 0. big R squared minus little r squared dx. Easy enough? All coming back? No? See why I waited on this section. I was like, oh, this would be a good one to do after spring break. All right, so the next one. So let's try to sketch it out. So this is the equation y equals 6 over x. So if you didn't know what that looks like, you can graph it on your calculator. Do you know what it looks like? Do you know what 1 over x looks like? This looks just like 1 over x, only it's been vertically stretched by a factor of 6. So instead of being at the point 1 comma 1, it's at 1 comma 6. Like that point's there. We don't really need that, but whoops. Come back. Oh, I hate that when I delete it and it won't come back. All right, so then we have y equals 6. And we have x equals 6. So we get a shaded region right here. And we're going to rotate around the line x equals 6. So here's our x equals 6 line. That's what we're going around. Do you see what shape is created? Yeah, kind of like a bowl, right? So it's going to look like that. Yeah, filled in bowl. There's no like open part to it. Exactly. You get it? Kind of comes down to like a little tip or something. Yeah, a distorted sphere. Yeah. Okay, so what do we have? So now this is a little bit different. There's no inner radius. What else is different about this problem? It's integrated with respect to y, exactly. So we're going to set it up, and if you want to write yourself a little note and be like, okay, it's going to have a dy, you can do that. That helps me kind of think through, okay, everything that goes in here has a y. So I'm going from a y value to y value. Well, I don't know what those y values are. I want to find that one, but I do know that this one's y equals 6, right? So I'm at least good on the y equals 6 part. But I want to find this point down here. So I have to say, oh, I'm going to have this 6 over x thing intersecting with x equals 6. Can you guys tell where it's going to intersect? X equals 1. So what's the y value then? Yeah, it's going to be 6. Is that right? Is that what I want? I don't want that, do I?
No, it
What
would
did
be 6.
Oh, I went around the wrong line, didn't I? X equals, where am I? X equals 6. I don't know what I did. All right, let's try this over again.
You went from y value to y value, so that's
from 1 to 6. So is y equals 1?
Yeah.
I should have done, I don't know what I did. 6 equals
Is that x
6 over,
6?
yeah.
It gives us that.
So I should have done my equation. I should have done it as x equals 6 over y. That's my issue. So I need to do 6 over y equals 6. Well, I'm trying to find the y value, so it would have been easier for me to do that way, right? All right, so I get y equals 1. So it's 6 comma 1. Yeah, so Cole was right. What I was saying is I had found x equals, what did I found? X equals,
Well, you set that.
I found x equals 1, and that was finding this intersection. Yeah. All right, so anyway, so I'm going from a y value of 1 to a y value of 6. Good? And we need our big R squared. Is there a little r squared? No. So what's our big R? Because I've been shading the region. It helps a lot, doesn't it?
I shaded the region before. But
So my big R is what?
Wait,
6 over y equals
6 minus 6 over y. So I'm going to have v equals pi, 1 to 6, 6 minus 6 over y squared dy. You with me? Why am I in terms of y? Because I'm integrating with respect to y. Lydia, did I lose you on the 6 minus?
right.
So it's,
Oh,
so I drew my line the wrong way. Is that what my issue is? I did draw my line the wrong way. Bonus point for Lydia. It should be this way. You're right. So it should be big R should be
Yeah,
6
like-
minus.
I know.
It ended up being the same, but that was a coincidence. She's right. I should draw it horizontally because that's my radius, right? Because what I'm doing is I'm creating these circles that have an area, and when I add up all the areas, I get a volume. Just like when we learned Riemann sums and we added up all the areas of these rectangles to get the total area. That's what we're doing. If I stack a bunch of quarters on top of each other, I get a volume, not an area. Okay? So all those infinitely thin rectangles were like their heights. All those heights added together end up being the area of the rectangle. All right, so anyway, so I get 6 minus 6 over y squared dy. All right, and then we go from there. All right, so next one. So I have y equals the square root of x. And then I have y equals negative 1/4 x plus 4. So up 1, 2, 3, 4. Down 1, right 2. Down 1, right 2. So it's crossing somewhere way over here. Good? All right, so I could put this into the calculator. I could find the intersection point. I'm going around the x-axis, so I'm going this way. So I'm going to have an outer radius and an inner radius. What is weird about this one?
It's split.
So I have my outer radius, and I actually don't have an inner radius, but it switches, right? So it's, okay, let me draw. So my outer radius changes right here. So my outer radius is a certain thing for a little bit, and then it's something else for a little bit. Yeah. So I made this one a little bit harder for the other class. I'm going to make it a little bit harder for us too, because I'm mean. All right, let's make it, because I was like, I could have swore I had an outer radius and an inner radius, because I changed it from around the x-axis. Let's say around, let's make it even harder, around y equals negative 2. I like a little bit of a challenge. Okay, so we're still considering that, like, that point right there where everything changes. Okay, but do you see how we have an outer radius and an inner radius? And then that outer radius and inner radius changes. Outer radius and inner radius. The inner radius is actually the same for the two of them, but see what I'm saying? So for the red lines, so if I just figure out the volume of the left part here, what do I get? I'm going to have my pi. Am I integrating with respect to x or y? X. So my outer radius is going to be square root of x minus a negative 2, so plus 2. Do I need to write that out somewhere? So my big R is square root of x minus a negative 2, which is square root of x plus 2. And my inner radius is going to be what? 0 minus a negative 2, which is just 2. So I'm going to have my outer radius squared minus my inner radius squared. And I'm integrating with respect to x. And those x values go from 0 to question mark. How do I find it? I find the intersection point, exactly. So off to the side, I'm like, well, when is square root of x equal to negative 1/2 x plus 4? A little messy there. All right, it's a really easy number. Think about numbers you can take square roots of. 0, not 0. 4, let's try it. Plug it in. Square root of 4 is 2.
It works.
It works. So you could use your calculator, or you could be like, oh, it's magically 4. All right, and then we're going to put 4 up there. It's a 4. Got a little messy there. So 0 to 4. And then what? Plus pi going from 4 to, what's this intersection point? 8, 0, right? So we would say, when is negative 1/2 x plus 4 equal to 0 at x equals 8? Oh, trying to make that nicer there. All right. And then what? Now I need this new outer radius and inner radius. So this outer radius is going to be negative 1/2 x plus 4 minus a negative 2, though, right?
Oh, yeah, sorry, minus
So plus 6, and then the inner is still that 2. That's it. If you can do that, you can do anything. You can totally do that. All right, the only thing with number 5 is I don't think some of you guys know how to graph natural log. Maybe you can prove me wrong. Do you know how to graph natural log? I know Cole does because he's like the master grapher. He knows how to graph everything. We used to have a student a long time ago, probably in my first or second year here, and we would just like throw any function at him to see if he could graph it. Maybe we should do that with you. Be like, what does this look like? You graph it. All right, so natural log of x. Any ideas? Vertical asymptote or horizontal asymptote? Nope, vertical. You had a 50-50 chance, guys. All right, think about it. Can you take the natural log of a negative number? No, so there can't be anything over on the left-hand side because we can't take the natural log of negative numbers, or 0, right? And it has to cross through 1, 0, because when I plug in 1, natural log of 1 is 0. So it looks like that. All right, so it's trapped by that, by y equals 0, going from x equals 1 to x equals 3. Actually, telling you x equals 1 was kind of redundant since I had said it was trapped by y equals 0 as well, but that's okay. So there's our piece, and we want to go around the x-axis. Super simple. Oh, is it 4? Did I draw that 4? So I'll make it smaller. Thank you, Alexis.
Not a direction.
All right, so we're there, and I'm going around the x-axis. So do I have an outer radius and inner radius, or no?
Just an outer.
I am 3 for 3 today, back from break. Wow, just so you know. All right, so yeah, which is an outer radius, right? It's the little things in life, guys. You what?
Like we went from something crazy to just.
Yeah, this is easy, right? Natural log of x, that's it. So your volume is going to be pi natural log of x squared, going from x equals 1 to 3, and that's it. But you know how to integrate that? Not without Math 9, right?
Of course I do.
How do you integrate natural log? You don't know how to do it. I've never told you how to integrate
Oh, I
natural
thought
log.
we were.
What is it?
The derivative of natural log is 1 over x. You do something called integration by parts, which we have not learned. So you would use your calculator
Are
for
we
this one.
going to learn it?
We were going to learn it after the AP test because it's not on the AP exam.
Fantastic.
All right, last one. So let's not make this around the y-axis. So let's do some that are actually in the next section, which we've already done, that volume of other cross-sections, right?
Okay.
So we'll do a part A and part B on this. If you need more room, you can put it in your additional notes. So we have 9 minus x squared. Where does that cross the x-axis?
Oh, the negative.
At 3 and negative 3.
Yeah.
And we're going from 2 to 3. So we have this little shaded region right there. And let's say for part A that we want squares perpendicular to the x-axis. Okay, so with that, we would have basically these little squares coming up off of this in 3 dimensions. It's very hard to draw. So coming vertically off this page, like this, you have a square, right? Get what I'm saying? So that square has a certain side length. What would be our side length from here to here? 9 minus x squared. Depends on what our x value is, right? So the area of the square is going to be the side multiplied by itself, right? Side squared. So it's going to be 9 minus x squared squared. And how do I get the volume? I integrate the area, right? That's what we were doing with those volumes of solids of revolution. We were finding the area of a circle, which is pi r squared, and we were integrating it, right? That's what we're doing here. So we're going to have 9 minus x squared squared dx going from an x value of 2 to 3.
There's no pi.
There is no pi. Why is there no pi? It's a square, which has an area of side squared. Not pi side squared, right? That's it. All right, what if we do equilateral triangles?
No. It's what?
Perpendicular to the y-axis. Yeah, did I tell you guys how to find the equilateral triangle formula?
Yeah.
So we know our area is going to be the square root of 3 over 4 times whatever our side is squared, right? But now we're going perpendicular to the y-axis. What does that mean? It means we need to integrate with respect to y. So he's saying invert the equation. Do you guys know what he's saying there? So we have y equals 9 minus x squared. We're going to change it into x equals, right? So I'm going to do y minus 9 equals negative x squared. So x squared is equal to 9 minus y. Right. Negative y plus 9. Then what? Square root. So I get x equals plus or minus the square root of 9 minus y. And since it's only the right side, it's only positive x values. The left side would be the negative x values. All right, so our side then, we now have this picture like this, and that side there is from right side to left side. And we have these little triangles coming up off of it. Right, so really technically I would shade my region here. And then I would say, okay, what do I have? I have this little triangle from here to here. So my side then is going to be, what do you think? Is it the square root of 9 minus y? Minus 2. That distance was 2 there. That's 2. Right? Right side minus left side. This is the right curve. Minus left side was 2. Clearly drawn to scale. See how tiny my 1 is and how big my 3 is.
Is the axis of rotation ever going to be a curve?
No. That would be cool, though. All right, so we end up getting our volume is equal to, we said it was square root of 3 over 4, side squared, right? So I take that side, the square root of 9 minus y minus 2, and I square it. And my y values go from 0 to question mark. What is that? What two lines am I intersecting? I'm intersecting the line x equals 2 and y equals 9 minus x squared, right? So 9 minus 2 squared gives me a y value of 5, so it's 2 comma 5. So I go from an x or a y value of 0 to 5. That would be how we would do that problem. Did I just hurt your brain?
I kind of, yeah. Maybe.
Do I need to do one more like that, or you guys are good?
I think I'm good.